Okay, now we're doing the second part of 1.3. The first part was absolute value equations. These are going to be absolute value inequalities. And there's a couple of things that you're going to need to pay attention to. Remember with inequalities, we have and or. On compound inequalities, your absolute values are going to be compound inequalities. And if the sign at the beginning is greater than or equal to or greater than, that means you have an or problem. And if it's less than or equal to or less than, that means you have an and problem. All right. So and then that's at the beginning. So this first one, since it's pointing left, I know this is going to be an and problem. Okay. And I just note that at the very beginning, just so I know where I am. We're still going to go back and isolate the absolute value like we did with equations. Notice this one is already isolated, so that means I can go ahead and make my two equations. And the first equation is going to be whatever's inside the absolute value, the sign that you have, and the number. Okay, so it's just going to be like what you have, but without the absolute value. The second equation, you're going to take what's inside the absolute value, you're going to flip the sign, and take the opposite of what's on the right-hand side. Okay, so it's really important that you flip and take the opposite. So I'm going to point that out. You flip and opposite sign for the second equation only. And then you solve each of these. So if I subtract 5 from both sides, I have x is less than or equal to 3. Subtract 5 from both sides here, and I have x is greater than or equal to negative 13. Okay, I do like a sketch and then a final on my inequalities because I just think it makes it easier. So first I'm going to do what I call the draft or the sketch. And, excuse me, I'm going to do, you've got negative 13 and 3. Make sure you put them in numerical order. You don't want the 3 on the left-hand side because 3 is bigger than negative 13. And remember that this is positive infinity and this is negative infinity. And I know for this one, I'm going to have a closed circle, and my arrow is going to point left from 3. So closed circle, left from 3. And on the 13, I'm going to have a closed circle, and it's going to go right. Okay, and you'll remember from when we did started graphing inequalities, if you have an and, that means you have the overlap. And so that means, since this is an and, that means I'm going to have the overlap is what I'm going to keep. And so my final graph, that is the actual answer, is going to look like this. You're going to have negative infinity to positive infinity. We have negative 13 and 3, and it's just going to be the part that overlaps. That's your final graph. Because we're graphing the overlap because we had an and. The interval notation then for that, these are both closed circles, so I have negative 13 to 3, and it's going to be inside a bracket because it's a closed circle. Okay, so that's the basics of the absolute value inequalities. Now let's try this one. We've got our absolute value, and I'm going to highlight it so we isolate it. And remember, at the very beginning, we look at this to see if it's an and or an or. This is going to be pointing to the right, so it's an or. And we'll save that for later. That's information we'll need later. And I'm going to go ahead and solve my equations. So I'm going to isolate the absolute value and divide by negative 3. Now the absolute value of x minus 2 is greater than or equal to negative 2. And alarm should be going off a little bit because we have an absolute value on one side and negative on another. Now just because you have a negative does not mean that it's no solution. And the way that we look at this, the question we ask is, are any of these values oh wait, I should have changed this, shouldn't I? Okay, I hope you guys caught it. When I divided by negative 3, I should have flipped the sign. I didn't do that. And are any of these values positive? If yes, then you solve it. If no, then it's no solution. Okay. Now, the equation, and you'll notice now why it was so important that I have the sign go in the right direction, because now I have the absolute value is less than negative 2. Are there any values less than negative 2 that could be positive? And the answer is no. Okay, everything less than negative 2 is all negative. So this one's going to be no solution. If I had left it, if I had had a greater than sign, then I would have had some positive values, because if the absolute value is greater than -2, well, 5 is greater than -2, and that's positive, and so there's a possibility, then you would solve it. So you have to ask yourself this question, it's really important. Are any of the values going to be positive? Okay, if yes, you solve it. If no, it's no solution. All right, let's try another one. Okay, this time I'm going to solve. I'm going to divide by -3. Oh wait, first this is an and or an or. This time we don't have, it's facing left. It doesn't matter if it has an equals or not. It's facing left, and the ones facing left are ands. So that's going to be an and. Divide by -3. When you divide by -3, then I have the absolute value of x minus 2 is, whoops, I almost did it again, didn't I? Is greater than -2. Okay, because when you divide by negative, you flip the inequality. Now, if I ask the same answer, are there any of these values that are positive? Well, is there anything, the absolute value, is there anything greater than -2 that's positive? Well, yeah, 6 is greater than -2. So there is a possibility that something could work. So we're going to go ahead and solve it. So I'm going to do my two equations. The first equation is your absolute value, whoops, without the absolute value sign, whatever's inside the absolute value, and the sign that you have, and the -2. And the second equation is whatever's inside the absolute value. You flip the sign and you change to the opposite, so to a +2. So you have to do both, flip and opposite on the right-hand side. If I add 2 to both sides, I have x is greater than 0. Add 2 to both sides, and I have x is less than 4. Those are my two values that I'm going to graph on my sketch or my draft. I'm going to graph both of them on the same graph. And I've got 0 and 4. On the 0, I have an open circle going to the right. On the 4, I have an open circle going to the left. The and means I'm graphing the overlap. So my final graph is only going to be the overlap. So I have a 0 and a 4, and those are open circles, and you have the overlap. Okay, what they share, what they both have. Okay, then your interval notation is going to follow that. It's a 0 and a 4. They're both going to be parentheses because we have open circles. Okay, and I've got one more problem I want to do. All right, we're going to isolate. Make sure I've got it on so you can see what I'm doing. I'm going to isolate the absolute value. So I'm going to start by adding 3 to both sides. And I have the absolute value of 2x minus 5 is less than 10. And remember, you look at the original sign to determine if it's an and or an or. This one's pointing to the left, so this is an and. Okay, now that I've got the absolute value by itself, I'm going to do two equations. I have 2x minus 5, your absolute value, your sign, and whatever's on the right-hand side. On this one, I use my absolute value. Flip the sign, change the sign. Right here, add 5 to both sides. And I have 2x is less than 15. Divide by 2. And I have x is less than 7.5. Over here, I add 5 to both sides. I have 2x is greater than -5. Divide by 2. And x is greater than -2.5. Okay. Now I'm going to do on the draft, I'm going to graph them both. And I have positive infinity and negative infinity. I have -2.5 on this side and 7.5 over here because 7.5 is bigger. On the 2.5, it's an open circle because there's no line, there's no equals, and so then I'm going to go to the right. On the 7.5, it's also an open circle, but this one's going to the left. I have an and, which means I'm going to just graph where they overlap. So my final number line, or my final graphing, is going to look like this. I've got -2.5, 7.5. I have negative infinity and positive infinity. And I'm only graphing the overlap, so it's going to be the part in between the two, because that's the only part where they overlap. And my interval notation is going to be -2.5 to 7.5, and they're both parentheses because they're both open circles. And that's the last part of part 2 of 1.3.